Okay, so Rolle's theorem and mean value theorem. We're going to be working with both of those today. Just remember from last section, the extreme value theorem just said if a function is continuous somewhere on a closed interval a to b, must be a minimum and a maximum, whether that's the endpoints or some point in between, but they have to have a min or max. So that kind of goes into Rolle's theorem. Rolle's theorem says we have f is continuous on a closed interval again. A and b is included because they're brackets. And differentiable on the open interval a to b, so every point in between is differentiable. If f of a equals f of b, if that happens, then there must be at least one c in the interval ab such that f prime of c equals 0. So what does it mean for f prime of z to be, or c to be 0? That means it is a what kind of a number? Critical number. Okay, so if f of a equals f of b, there has to be at least one point where the derivative equals 0 between that a and b. So on the left, that is differentiable, correct? Nice, pretty. It's differentiable at C, isn't it? Is the second example differentiable at C? No. Has that sharp turn. So it's continuous, but it's not differentiable. So could I use Rolle's theorem on the right-hand one? No. You guys good? So find the two x-intercepts and show that f prime of 0 at some point between the two. So how do I find x-intercepts? What? Set it equal to 0 and solve or factor, right? Okay, factors of 2 that add to 3. So x minus 2 and x minus 1. So your x-intercepts are at 1 and 2. So now it says show, find the two x-intercepts. We did that. These are my x-intercepts. So it says show that there's some point between the two that f prime of 0, f prime of x equals 0. So now what do I have to do? Find what? Derivative. Find the derivative. So what is the derivative? Okay, so 2x minus 3 is the derivative, and then I set that equal to 0. So my critical number would be x equals 3/2. There's 3 halves in between 1 and 2. Yes. So we just showed Rolle's theorem worked. Questions?
No.
Okay. Riley, you good?
Yeah.
Okay, let f of x equals x to the 4th minus 2x plus 2. Find all values of c in the interval -2 to 2 such that f prime of c equals 0. So what do I need to do? Find the x-intercepts because I need to show that there's points in there that they're equal, yes? So 0 equals, I would assume you'd factor out an x squared. So then you have, what, x squared minus 2? So x equals what?
2 and 2.
2
and 2. 0 and the square root of 2.
0 and plus or minus the square root of 2? Don't forget your plus and minus. Okay, so did we show that there's some a's and b's in between -2 and 2 that like equal? Because the square root of 2 is definitely between -2 and 2, yes? Okay, so now what?
I'm going to find the derivative.
Find the derivative. And?
4x3 minus 4x.
Okay, and do what with it?
That equals 0.
Factor out a 4x. And that would leave you x squared minus 1, which would be x plus 1 and x minus 1. So my critical numbers would be what?
0 plus minus 1.
So the interval -2 to 2, where are my points? We probably should do -1, 0, 1, because if we were to graph, then we'd see them, right? So can there be more than 1? Yes. Now, if I got a number that wasn't on the interval, what would I do with it? Cross it out. But one of those numbers has to be on the interval, right? Because that's what it says. Questions?
So like that plus or minus square root of 2, like we don't have to put that in the end?
No,
It's
we don't
just
have to
the
do
x
anything with that. We just had to show that A equaled B somewhere on that interval.
Okay.
Because we were looking for that F of A equals F of B. Okay, the mean value theorem. The mean value theorem says if F is continuous on a closed interval A to B and differentiable on the open interval A to B, all of them have to be continuous and differentiable for these things to work. If they are not, they don't work. That's it. Okay, then there exists a number C in AB, so C is some number between A and B, such that f prime of C equals f of B minus f of a over b minus a. Okay, is that not the slope? Y minus y over x minus x? Yes. So there's some value of c that they will share the same slope. So what it's saying is the slope of the tangent line is equal to the slope of the secant line at some point. Does that make sense what I'm saying? So the secant line that runs through A and B, right here, that slope will match some point's tangent slope. Which it should, right? And we're not going to do the proof yet. We're going to trust somebody way smarter than us knew what they were doing. How about that? Sorry. I didn't see your pencil moving.
I can't take you serious today. Let me see your nails. Are they done?
No, tonight. They get done today. Is it pretty?
You're such a pretty weird Barbie.
Good now? Okay, given f of x equals 5 minus 4 over x, find all values of c on the open interval of 1 to 4. So, open interval, are 1 and 4 included? No, open means not. Such that f of x equals f of 4 minus f of 1 over 4 minus 1. And I will let you in on a secret. I wrote that better. This is how they wrote this in the book. 5 minus parenthesis 4 slash x. Isn't that absolutely ugly?
It's okay to me.
Ugh, ugly to me. Okay, well, I'm going to start off by finding this. Okay, so I have 1 and 4, so I probably need to plug 1 and 4 into the original to get the answers, right? So if I plug in 4,
4 and 1.
so 5 minus 1 is
4.
4 minus, and I plug in 1, 5 minus 4 is 1 over 4 minus 1, which would be
0. Wait, 1.
1. Yes?
What'd you do? Yeah, 1.
F of 4, plug in 4. What do you get? 4 divided by 4 is 1, 5 minus 1 is 4. And then plug in 1. 4 divided by 1 is 4, 5 minus 4 is 1. I hate that it worked out that way, but it did. So that's the slope of the secant line. This is the secant line, yes? So now we need to find the
Tangent.
slope of the tangent. So we need to find the derivative. Find all values of c on the open interval 1 to 4 such that. So I need to find the derivative, which is
0.
No, because this would be 5 minus 4x to the negative 1. So then that would be 4 x to the negative 2 or 4 over x squared? Yes?
Yep.
So then we need to set this equal. This should have a prime. I was like, this is written wrong. Because the theorem is prime, yes? Okay, so I should have wrote it right here. So x to negative 2. So 4 over x squared. So I need to solve for
X squared.
x squared. So I would assume we'd multiply over by x squared. Everyone on board with that one?
Yep.
And then square root. So x equals
2.
and
1. Oh.
plus or minus 2. Now, are they both good answers?
Yep. No.
Yes or no?
What do you mean?
Plus or minus 2?
No, not negative 2.
Not negative 2, why?
Because you have a 1 and 4.
Because our interval is 1 to 4, so our only answer is
2.
2. Because negative 2 is not negative 2 is not, I can't get it to right and then I write the wrong thing, is not in 1 to 4. Did everyone get that prime added to your problem? Questions on that?
No.
Ainsley, what's wrong?
I'm just trying to understand it.
So I'm asking, can I help you in any way? What? That's it?